Okay, we are recording. Welcome everybody. This is the Spring Boot Java workshop. My name is Max. Today we're gonna follow this repository. You can all find this in Nighthacks. If you just Google Nighthacks GitHub, it'll bring you here somewhere. You can find the workshops repository here, and then 2024, 2025. And then here it's going to be under tech exploration. And the name is Java Spring Boot. Okay. This is already a finished version of the app. I don't know how close we're going to get to this, but we'll try to finish it up in like 1 hour, hour and a half. The front end is already built. So I'm just going to show you what the end result of what we're going to be doing is going to be like. So this is what we're going to be building. It's I call it a clicker challenge. This is a little game that you start the game and you start clicking, and you try to get in as much clicks as you can in 5 seconds, and then you can kind of authenticate and enter your username, and then in the score sheets, yeah, we're gonna have some users in here, and there's gonna be we're gonna be able to visit each user and go into their sort of all of the user attempts that they had in this game. And the game is going to look like this once you start the game. I'm just going to have like a test go. So it counts down 3 seconds, and then once it starts, you can click, you can play. 5 seconds passed. I know it's a silly game, but yeah, I scored 29. Now I'm going to go into scores. I don't think I authenticated. Let me authenticate. So MaxCP, that's my nickname. So the authentication is going to be simple like this because it's a short workshop. And yeah, so if I go again now that I am authenticated, so it is going to like bring me to, it's going to record my score, and we're going to build a backend for this. So let's first start with setting up our environment. We can follow this README for that, but I'm going to walk you through everything here, okay? So how many of you guys, okay, let me start out generic. How many of you guys know Java, at least somewhat? Okay. So there are some enthusiasts in Spring Boot who don't know Java, right? You don't know Java, okay, good. No worries. This is a friendly workshop for beginners as well. I'm just gonna be saying some concepts, but that might not make sense to you at this point, but you'll still be fine. You'll still learn a lot here. We're good. All right. Now, please raise your hand. How many of you has a JDK installed on their computer? JDK, which is essentially Java. If you ever ran Java on your computer, you have JDK. Okay, so two people. No worries. Okay, we're gonna go through that. Okay. How many of you guys have VS Code? Can you get some VS Code? Okay. All right. So whoever doesn't have VS Code, unfortunately, you're not going to be able to follow. But you're also welcome to watch. I think there's only one guy, right? Do you have VS Code? You're just watching. Cool. Okay. So yeah, first off, let's go to VS Code, and we're going to need to install 2 extension packs. Okay. So go into VS Code. This is VS Code, right? Everybody got pulled it up. And then I'm going to go into extensions right here. It looks like a building blocks, or yeah, like 3 blocks in here. And I'm going to search up this one right here. So install Java extension pack by Microsoft. You guys here for Java Spring Boot workshop? Okay, awesome. You almost didn't miss anything. So yeah, once you search this up, Java extension pack, this should be the one by Microsoft. Okay, so once you search it up, open this one up, and it's gonna say install for you guys because I already have it installed. It's disabled, but you click on install. Once the installation is through, it's the IDE is gonna be smart enough. It's gonna ask you guys if you have a JDK or not, or rather, it's gonna point you out that you don't have a JDK. Like, go ahead and install one. So once you get that pop-up, just select JDK 21, or 17. It's going to work with both of them, but we prefer 21 because our repository uses 21. And once we start from scratch, even if you choose 17, you're going to be able to set 17, okay? Was everybody able to install this? Okay. Who? Let's see hands. Who here is trying to like follow me, or should I just go like straight into the demo? Who's trying to follow me right now? 1, 2, 3, 4, 5. Okay, yeah, we're gonna give you guys time. So yeah, you can let me know once this is installed. Essentially, you are supposed to see like a pop-up JDK 21. Did it show the pop-up?
I didn't have the pop-up.
Oh, you already have. Okay, you got a pop-up. Let's check it out. Okay, so you're gonna go ahead and open terminal right here in VS Code, right? It's gonna be different on your system. If you guys have Windows, go terminal, new terminal. Should open it in whatever repository you are, and go ahead and type Java -- version. And you guys are gonna see on my example. By the way, is this good visibility? Is this okay? Okay. You're gonna see OpenJDK 17. JDK stands for Java Development Kit. That's actually what we were trying to install. When I say you guys have JDK, that's exactly what I meant. I'm using 17, like I said. It's also going to run with 17, but 21 is preferred. Did you guys get this, or some of you got error messages? Good? You got it? You didn't get it? What do you mean taking a little bit? Like this command taking a little bit, or the installation? Gotcha. Interesting. Okay, so if you didn't get a pop-up for this JDK installation, you can just go to like download JDK for Windows, right? You have Windows. For Windows, Java downloads Oracle here. And then, oh, by the way, I forgot to put in the version, say JDK 21, right? Just to be more specific. JDK 21. By default, gives me 23, but you can switch to 21 here, like this. And you choose the version you have. If you have Windows, I believe you click here, and there's only a installer. Yeah, installer is the best one, I think. For Mac, I probably would have to do the DMG installer. Yeah, there you go. Once you have it installed, if you do this installer, it's nice because it sets your Java home environment variable. Once you have that set, that command Java -- version is going to work essentially. So that's what's nice about these installations. And same here. If you follow the installations in here, it's also going to let you install the JDK. Okay, so I'm assuming everybody's good. Anybody needs more time, or everybody's good? All right. Next step is going to be to install the Spring Boot extension pack by VMware. This is going to be the last thing we need to install, I promise. Search up Spring Boot extension pack. Spring Boot extension. Yeah, Spring Boot extension pack. And the author is going to be VMware. All right, VMware, hit install. I already have it installed. It says disable here. Once you have this installed, you're going to need to restart the whole IDE, and we can proceed. Okay, I'll pretend that I also installed this, and I'm going to restart my IDE. Okay, I'm going to go into command OSG. Okay, we're going to say, all right, I'm not going to touch anything. So code. Oh. Okay. Did the Spring Boot extension pack installed? Nicely. Okay, good. All right. So what is exactly Spring Boot, right? So Spring Boot is an evolution as compared to just doing classical backend in Java. So back in the days, there was a thing called Java Enterprise Edition, which had a bunch of sort of standards for how like different vendors have to implement receiving HTTP requests, like connecting to the database. And you had to do all these things manually. When Spring just started, they had a bunch of different frameworks like Spring Web, Spring Data, whatever, for the same purposes, right? And they did improve things a little bit in terms of not configuring as much of things, but it was still kind of not united. What Spring Boot does, it reunites all of these technologies, and you're actually going to see from this tutorial, or from this workshop rather, that developing with that became that much easier. Developing with Spring, developing backend in Java is so much easier now. It comes at a price, though. A lot of the things that we have to configure are behind the scenes, and I'm actually a proponent of like learning the fundamentals as well. If you're interested in that, like if you plan to also have Java development, backend development experience is one of your skills, I do recommend learning these like fundamental technologies, and I believe they teach them here at UCF in the class Enterprise Computing. I think it's one of the electives. Knowing those fundamentals is nice. It's going to really help out here, understanding what's going behind the scenes. I'm also going to be explaining here and there what's going behind the scenes, but mostly this is going to be really beginner-friendly, and for that, thanks to Spring Boot, okay? So Spring Boot consists, like I said, of like data frameworks, web frameworks to work with, like to accept HTTP requests and everything, what we're going to be doing today. And to get started with Spring Boot, we need to look up Spring Boot initializer. Oh, shit. Initializer. Okay. It's going to look like this. There is an alternative to do it in an IDE. If we were using, for example, an IDE specifically for Java development, like Eclipse or IntelliJ, then there would be an alternative to do it like in that project. But we're doing VS Code. VS Code, I would say, is about 80% as functional as those IDEs, but some of the things are missing, so no worries. So this is still a good tool to initialize a Spring Boot project, okay? So in the project over there, we're going to choose Maven because these are essentially build tools. If you know other development, these are equivalent to like npm. You know, npm like a package installing manager. This is equivalent. It's essentially a little bit different in terms of that. It also takes care of like dependencies and compiling things because Java is a compiled language. So those really take care of that. Okay, so we're going to be using Maven. That's one of the most easiest and popular ways. Gradle is a little bit more complex. Okay. We're going to be doing Java. This is a Java tutorial. And version, the default is fine. Here in the group, this is Java-specific stuff for like really naming your project and giving it like an artifact ID and stuff like that. So for group, we're just going to go with defaults here. The only thing we really need to change, I think, yeah, we don't even need to change anything. Jar and var. So essentially, jar is a compiled version of, it's like a library. Think of like in terms of JavaScript, right? That would be or rather in terms of C, right? Everybody knows C here. Think of that as like a library that is like comes external. You have a header file, right? You have a compiled actual C file. So jar is something like this. It's already compiled. It's already ready to be like executed in the computer, and you just call Java like execute, and that's really nice about Spring Boot as well. It just makes you a single artifact like jar file, and you're able to just put it on your server. Don't worry about anything, okay? Last thing we need to really configure is these dependencies right here. So we're going to be including Spring Boot DevTools. Just remember this for now. And we're going to be also adding Spring Web, okay? Everybody good here? Spring Boot DevTools, Spring Web. And then what else? Okay, this is nothing. We're gonna click generate projects right here, and it's gonna let you download this file, and it's gonna be named the same as your app name. We just left everything by default, so our app name is gonna be demo. Okay, I'm gonna open this. I'm gonna unzip this. Perfect. Probably rename it to something like demo. Now demo already exists. I'll delete this one. Just bear with me. All right, awesome. And I'll move it to that directory where I want it to be for my VS Code project. All right. Nighthacks, where's Nighthacks? I lost Nighthacks. Okay, here's Nighthacks. Awesome. Take exploration, Java Spring Boot. I'll just have it here somewhere. And then once you export that, I'm also assuming that your Spring Boot installed, your Spring Boot extensions here installed properly. So once they are installed, we're reloading our VS Code. I'm gonna navigate into that demo project. So cd Spring Boot plus cd Java Spring Boot, cd demo. Okay, demo is the directory, and I'm gonna open VS Code from here using code dot. So once you really have your both Java extension and Spring Boot extensions, you're gonna see here in the bottom, right here, Java project. Okay, so a more convenient way to view the file system would be to close this one right here and to use this one, Java project. And I'm gonna close this as well. I'm gonna minimize these. Good. So once we unpack this, the main file, we're going to briefly go over the files in here. Don't be scared by all these files. Really, only a couple of them really matter. Main files are in src main Java. This is where if you like unlock it, this is where your demo application lives. This is the method that really starts your Spring Boot application. And then here, resources, here where we're going to be putting our static files and application properties. This is almost empty for now, but we're going to add some stuff here later. And then here, here would be the src test Java file for all of the testing Java code. You're going to see here a quick JUnit test, I believe. Yeah, the default Spring Boot comes with a JUnit, which is a testing framework. Excuse me. And then what else is important here? I guess let's go over the MVM files, right? So MVM is Maven. Remember the thing we configured in here in the equivalent of npm, right? The manager of like dependencies and build process. This is just for those people who don't have npm, who don't have Maven installed on their system. If you remember, I didn't ask you to install Maven. This script really here takes care of that. That's a Maven wrapper, and it's responsible for installing that Maven thing, which is in turn going to like compile our Java files. POM.xml here is a file that manages our dependencies and kind of like information about our project. If you remember, in the initializer, we entered like the project name, the project version, stuff like that. Everything is here. This is XML format. I believe here people know at least HTML. This is similar. XML is similar to HTML, same format, right? This is just a way to specify like these properties of the project, right? And some dependencies here as well, like the version of JDK. Everything is here. Although I believe on my system I have JDK 17, so I'm just going to go ahead and change this to 17 right here, okay? Yes, please. Okay, but you can leave it as 21 because I asked you to install 21, right? But I just have 17, it's fine. And then as far as these are really not that important. This is just an MD file. Tells you some info about the Maven. And .git are the files for our repository, just auto-generated repository. We don't have to worry about that for now, okay? VSCode.mvn, those are also some configs files. So essentially, this is just that. And in order to run this project, the Spring Boot project, this is going to be literally a hello world project. There's gonna be a button here. This is only gonna work if you're in Java projects right here, right? If you're just in here, you're not gonna, for example. Oh, I guess it does work. Okay, so, but my point was, if I right click here, I'm also able to run here, right? But that's not the case with this demo right here. So that's why we prefer to use the Java extension and the Java project right here. Okay, so I'm gonna go ahead and click run, and you're gonna see a console open up here. And if everything was installed properly, this is gonna print out this message right here. It says Spring, and some of the log messages, we can go over them. It started Tomcat server. Tomcat is like a classic Java server that they use for all of their servlet specifications, the way how they decided is going to be a standard for handling HTTP requests. So Tomcat is just one of the servers. There are also many other servers, but this is the most beginner friendly. And Spring Boot also happens to come with it, which started up really without us configuring anything, right? And it also says in here, Tomcat server started on port 8080, right? So port 8080, this is something we're going to check out right now. I'm going to go into localhost, column 8080. Awesome. We're going to see this error. This is the classic error you see first time you launch your Spring Boot project, okay? So yeah, this is how easy it is to start a Spring Boot project. If you had to do it through IntelliJ, that would be an entire process of installing IntelliJ. That would be, we would be at least looking at 2-3 gigabytes minimum, but this is a nice way to do it in VS Code, okay? Now let's really dive into some Spring Boot theory and how to really accept requests. So let me first ask, everybody here kind of approximately knows how APIs work, how like requests are handled in the web, kind of, sort of? Okay, let me actually then explain this quickly. So most of the architectures today use sort of the client-server architecture, okay? Clients are the browsers, typically just a compilation of like HTML pages, and they in turn have something we call scripts, something we call like JavaScript files. And each of these JavaScript files have some code that helps make the page interactive, and that in turn sends some HTTP requests. That's just a standard that they call HTTP. It stands for Hyperlink Transfer, and another T for something protocol, last P for protocol, okay? Hyperlink Text Protocol. Yeah, there you go. And that standard is what they use to communicate from one computer to because client and server, they're essentially just two computers. Server is a computer that is running somewhere in the cloud or in somebody's like premises. Maybe here in UCF we have some server rooms. There are computers constantly running, and what they are responsible for is accepting all the requests from the client. You know, all that JavaScript code that they send using HTTP, and responding to those. So imagine, let's say, Google, or let's use Facebook, actually, Meta, right? So imagine a Meta server and a client sending a request to a Meta server. Then that server really, what it must do, it must sense that request was sent. It must see what the request is. Maybe user is asking for a specific resource. Maybe he's asking for a compilation of like, hey, I want to see this list of users that this other user has as their friends, right? Whatever. The requests are really different. And this is also part of the art of like building these endpoints to handle like how different requests are looking, how what's the sort of protocol that we're using to handle the requests, and how to answer them, what to send back, so that the front end, the client, can really like process all of that and put it back into the page so that the user can have a nice user experience, right? This is sort of like a non-official explanation. So this is essentially what we're going to be doing today. We're going to be building a backend for our front end that's already pre-built. So we're going to get to that. First, let's talk about how to handle a simple HTTP request, because right now we are handling this request, but it's being defaulted to an error page, right? What we're going to do is we're going to create something that's called a controller. Controller in Spring terms, that would be like I'm assuming some of you guys know Express, right? That would be like a route, essentially, in Express. Okay. I'm going to go ahead and right-click here in the COM example demo. I'm going to click New Class. So everything in Java is a class. Surprisingly, it's an object-oriented language, so I guess it's a nice property. We're going to call this controller dot hello controller. Okay, we're just going to name it like this, .java. So the first subscript is, this is the package name. Okay, you're going to notice that here We're also importing org.springboot, spring framework.boot. So this is essentially also a package. This is how just a Java way of organizing your classes neatly, right? And we're going to put this class in the controllers. You can really think of it as a directory or like a folder in your computer, all right? So I'm going to create this class, and I'm going to annotate it with REST controller, okay? So if you really type at and then REST, it's going to auto-populate. The IDE is pretty much smart enough to be auto-populating. That's part of the reason we installed the Spring Boot extension, okay? So first of all, what is an annotation, right? In Java terms, annotation is one of the properties that the language supports for essentially marking data as something, for the compiler to be able to know that property that we marked it with at runtime. So essentially here, we're telling the compiler, hey, this is a REST controller, and in turn, a compiler or a runtime environment in this case is going to know that it's a REST controller, and it's going to treat it as such and plug it in places where it's supposed to be used. Okay, so we marked it as a REST controller. Now here, inside of the class, we create methods that we're going to be now marking as really the REST, how to call them, like the REST endpoints that are going to be answering some of our REST requests. By the way, REST is also something I need to explain. This is an architecture that uses JSON as a substance that is being sent between client and server. So JSON looks something like this. Let me create a new folder. So I'll even just show it here, okay? JSON is essentially a string at its core, and it looks like this, if some of you don't know JSON. So it comes as a key value pairs, right? So key equals some value. Both of them are strings, right? In this case, they're strings, but there are also different JSON rules that accept like key2 to be just a number, right? Not a string. And this is just an encoding format of like how to be on the same, so that the front end and the back end are on the same page about what type of encoding we're using to send this data, right? Because at the end of the day, we just need to send this data, and backend needs to know, okay, I'm looking at the key property, and then I'm, for example, decoding it and getting a value or something that the front end send me, right? So this is JSON, and that's why they call it REST controllers. REST API kind of architecture is the architecture that uses these JSON controllers. You can think of it as that for now, okay? So now I'm going to create a method. This is going to be a typical Java method, public. We're going to say it's string, and then hello controller, or yeah, let's name it hello test, okay? And it's going to return a string. We're going to say hello Spring Boot, semicolon. And in order for the Spring Boot to understand that this is going to be a controller that handles GET requests, we're going to annotate it with GET mapping. Okay, so GET mapping, and oh, it already auto-populated something. I didn't want that, so I'm going to remove that. GET mapping. I'm just going to use this one. Okay, so it did auto-import. By the way, all the auto-imports are something that keeps the job easy for us. It just automatically imports all of the classes that we're using here, because at the end of the day, the annotation is also a class that was defined somewhere, and we need to have appropriate imports for that. So get mapping, and we need to follow that up with the URL kind of like route that we're going to be setting it to. So for example, in this case, we're going to say test. And this is going to indicate, so once user hits test endpoint, they're going to be dealing with it. This is going to be the handler that handles this request, all right? So I'm going to save it. As you can see, Spring Boot is not complaining about anything. There's no error logs for now, so we're good. And I'm going to go ahead here and say /test. And we're going to receive our response how we were intending. So this is nice, okay? This is our first controller. But now the question comes, how do we make it dynamic, right? How do we really respond back with something that users send? Because if we're sending back the same thing, it's really not useful, right? We can have to make it a little more complex, right? For that, we're we're going to see this next example. All right. Hello, test 2. All right, this is going to be a test 2. So now let's add here inside of the arguments of this method, let's add request, or rather path param. There you go, path param. And we're gonna just, for example, let's call it key, okay? Or name. So let's call it name. And in here as well, I'm gonna add a sub path, and this is gonna resolve to name as well. This is a Spring Boot notation, how you can like make this path parameter be extracted from the link. And we're also forgetting a return type. So this is a string path parameter. Was this not imported? That path parameter. All right, let's see here. Path parameter define attribute value. Path variable, my bad. It's path variable, not parameter. String name. So this name now, yeah, is being extracted. That's why these IDE extensions are really handy. They point you out all of the wrong classes that you set. So now what we're really going to do is we're going to say hello, and we're going to greet this path parameter that we send in here, right? So we're going to say name. This is just a common Java syntax to append a string to another string, or rather concatenate them, right? So let's try out this second endpoint that is now dynamic, right? We're going to go test2, and we're going to say Max. It's going to say hello, Max. If I say hello, Sam, it's going to say hello, Sam. That's how we do. That's how we make how we pass these sort of arguments into our endpoints, right? As you know, HTTP standard. So I'm just going to pull up this graphic. HTTP methods. There are some common HTTP methods that are used for serving and for the communication between the client and the server, and those really are the major methods that are used, and these correspond to sort of the operations that we really need to do. For example, get really just gets you data, lets you request the data and retrieve the data, right? Post lets you, oops, I didn't mean to do that. Post lets you send the data to the server and maybe store something in the server. Patch lets you alter the data that is stored in the server. And then put, patch and put, they're almost same. Patch kind of deletes the previous one and then overrides it with a new one, and put it just or vice versa. Put does that, and then patch really just edits the already existing resource, and then delete, obviously it requests to delete some data from the server. Okay, so we're going to see how some of these work, and for the purposes of our application here, by the way, you also notice that once we first just got into our application, like the root was not configured to point to anything, right? We did configure eventually our APIs to be like test or something like that, right? But the root is still empty. So the way Spring really lets you deal with this nicely is you can put your static like front end stuff into this designated resources folder, and that's how it's really going to be able to like serve all of your front end stuff, right? So let me open up this front end front end folder, and I'm going to copy it over to or actually, I really only need some of its some of the stuff that is here. Okay, so I only need this index.html and some assets. Okay, so this is what our backend is really going to be serving, and we need to put it into the, or not here in the demo, src main resources, and then static, right? Is that right? Yeah, inside of static, you paste all of your front end code, the index.html file, and then the assets, the JavaScript and CSS files that accompany your HTML file. So now, once we have these resources in place, you're also going to see them here as well. Now we're going to be able to essentially reload our server. I'm going to hit stop, and I'm going to rerun the server. And now, once we go into our root directory, what we're going to see is our HTML. Let's go back. Let's go into inspect. Right-click inspect, and then I'm going to go into network, and I'm going to rerun this. So you're going to see a bunch of files being sent. So these are really just chunks of this really big JavaScript file, because the front end code these days is pretty big. I already prepared this whole code for the front end before this tutorial, and this is already compiled JavaScript code for the front end, right? But it's pretty huge. As you see, it's almost, yeah, it's 200 kilobytes. So it did have to send it by chunks, but these are essentially all this file, right? This one single file. And this is the way you configure to serve these static files, right? Such as your front end code in Spring Boot. You really just put them in this static folder, and it scans this directory by default. And the way it really happens is through this. You remember we visited this demo application route, and not route, sorry, the demo application file, and it had this Spring Boot application annotation. So if I really Alt and click Control and then click on this annotation, it really is going to be a compilation of other annotations, one of which is component scan. So all of this configuring is really, like I was saying earlier, is done for us. And these, like serving these static files at the directory that are considered like a convention to put your static files, are really configured here in the scan annotations, okay? If you want to reconfigure them, it's a little bit of an advanced concept. We're not covering that, but essentially this is good enough for our purposes to serve our front end through the root directory, okay? And our other endpoints are still alive. If I go ahead and try test, this is still going to work. And the way it really works is that front end has some code that internally is going to call these endpoints, like test, for example. Test is going to return some strings, or in our case, it's going to be in the JSON format, and then it's really going to put it here in the front end code, and we're going to be able to like see the scores. Oh, in this case, since there's we still haven't configured that, we're going to see this error and see other pages also communicate with the backend. Okay, so now let's try this. Thus far, we've been getting requests for test. So we've been getting pure strings as an output. And now let's try to actually return some JSON. So how really is it is to return some JSON? One way would be is to just manually do JSON, kind of like, this is a hacky way, right? I can do this as in like response, right? Response. I'm going to just say res, and then column hello. But you're going to notice, you're going to see this is tedious. Okay, this is really tedious. So technically, yes, this is a valid JSON. Or probably I don't need these. Oh. Technically, this is valid JSON, right? We could really be doing things this way, but you're going to notice that we're going to see, as I show you, we have really cleaner ways to do things. So that really brings us to the concept of entities, right? Because in other frameworks, JSON can be really created from scratch from like any real object in that language, for example, in JavaScript object. But here we actually have to specify them, and they have to follow the sort of the file, the class structure that we defined here in our code. And like I was saying earlier, everything in Java is in terms of classes, okay? So I'm going to create a new class here, and I'm going to also put it in the sub package folder. We're going to call it entity dot test entity.java. This is traditionally, they call them entities, because part of the reason is because we do annotate these with entity. And you're going to notice that I'm not going to really have an entity annotation here. That is because these annotations, they really come from a different dependency that we didn't include in this project, and that I really wanted to just show you guys how we add these dependencies actually, in case we didn't already include something in the beginning when we initialize the app, right? So the way we actually do that is, you remember when we were reviewing our, let me minimize this, when we were reviewing our POM file, we saw these dependencies right here, right? And this is really how it's done. You just go into some online resources, you find your dependencies, and you place them here, and they obviously do have to match like the common specifications for these dependencies that you're going to be using, and you're going to have to know how to use them. But for that reason, there is a central Maven, central Maven repository, and all of the pretty much big Java or Spring Boot dependencies that are used in Java development are all here. You can search anything. And the one we're really interested in is going to be Spring Data JPA starter. I believe it's starter. So this is one other Spring Boot dependency that lets us handle data manipulations easily with the thing called JPA, which is really Java Persistence. I forgot what the A stands for, Java Persistence Application or something. So this is really a persistence sort of like specification that all the different vendors, such as like MySQL or PostgreSQL, different vendors of like SQL databases, they do implement. And it is supposed, their implementation is supposed to plug in nicely with this Java JPA implementation. Okay, so we're just going to select the first one. I think pretty much all of them are going to be same, considering we're also going to be deleting the version, and I'm going to get to that in a second. So first, copy this. You're going to notice here Maven, that's what we're using, remember? Maybe I'm going to copy this dependency, and I'm going to really just paste it here, okay? And I'm going to remove this version number because you're going to notice other things here. They also don't have a version number. This is a quick way for a starter project to be resolved to a same version number. Maven is smart enough to manage dependencies for ourselves. If we had to do it manually, then yes, we would keep this version thing, and we'd also have to add version to all of these dependencies, right? But Maven really does that. And dependency management is actually a huge problem. It's a whole separate topic. Dependencies do have to match, because some things, if some things change, the other thing is not going to work with it, right? But that's not the only thing we need here. Like I was saying, this is only the one side of thing. This is an implementation standard from the Java side, right? But now we also need the implementation standard from the vendor side, and the vendor we're going to be using is pgadmin. I already created a database, and I hosted it actually in AWS, so that we don't have to like go into the databases here. But actually, the database workshop is going to be tomorrow, so you're going to be welcome to also watch that and maybe set up your database locally. But we're going to be using Postgres database. So I'm going to go ahead and search up, oh, there it is, Postgres JDBC driver, okay? And this way, I'm going to receive these results. Postgres, the first one is the one. I'm going to choose it, and I'm going to select this latest version. Again, because we're going to be deleting the version number, and Spring Boot is smart enough to resolve the versionings. So I'm going to place it here. I'm just going to quickly align everything so that it doesn't look bad. Okay, so now once I save, you're going to notice here I get a pop-up. It really says a build was added, or the build file was modified, which means the build file for these dependencies are going to be added to our project structure, and it's asking permission to sort of like rerun and synchronize the whole class path so that Spring Boot really sees those dependencies, and they do resolve, and we can use them. Okay, so yeah, everything pretty much restarted. Luckily, no errors. I was really hoping to see some errors to let us maybe resolve something, but essentially, yeah, I will mimic some error scenario later, I guess. Let's see here. Let's see if this resolves now. So entity, now you're going to see, yeah, Jakarta persistence. Jakarta, why Jakarta, you're going to ask? Why not Java? It's a long story. It's like a acquisition type of thing. Some time ago, Jakarta got rights for Java, and they didn't get rights for the name, though, for the literal word Java. So that's why some of the things you're going to see are Jakarta. Also, not a topic for this tutorial, but essentially, if you let Spring Boot resolve all the versions, it is going to pick a correct one. Trust it. It is smart enough. Did I say Eclipse? I really meant Spring Boot. Eclipse is the IDE for Java development. Okay, so once I mark a class with entity, I'm gonna have to. You probably, those of you who know Java, you know that some Java classes, if they are encapsulated, right? If the fields are private, like in this case, like for example, private integer ID, you really need some getters and setters for this field because this is private. Other classes cannot really access this, so we need public getter functions or methods, how we call them here, right? So public integer get ID is going to be our getter for this ID, and it's going to return this ID field, and it's going to know that we're referring to our field right here. Okay, so I'm just going to quickly set up these getters and setters. Public void, these are going to be our setters to set the ID. This ID equals ID. Awesome. And we're also going to give it a name for our demos. It's going to be a string type, name, public string get name, and it also has to be in this format, like get and then the name of the field, set and then the name of the field. We're going to get into that a little bit later, but that's just a common convention how Java does things. Return name, almost done here. Public void set name, this dot name. This is one drawback of VS Code, that it doesn't automatically auto-populate this for you if you don't have a compiler or something like that. But Eclipse or IntelliJ, other like Java IDEs really do this for you. Okay, string, passing here integer ID. Okay, awesome. Now, last thing we need is a constructor with no arguments and constructor with all arguments. Once again, I'm going to explain later why we are making all of this extra work. Test entity, and then we're going to say no constructor. So this one is going to be empty. Public test entity, and this one is going to have integer ID, string name passed as arguments, and we're going to set its fields, this that ID, the same way we did before, equals ID. All right. One thing an entity in Java has to have is an identifier, right? So we are going to annotate it essentially with an identifier, and we're going to use our field ID here as well. We specifically created for that reason. So I'm going to say ID, and I'm going to call it, let me use my cheat sheet right here if you don't mind. It's just an ID property. This is how, and you have to import this. I'm going to click here, right? This is a convention of Jakarta persistence as well. This is a persistence kind of protocol to have your fields. If you're going to be mapping these to actual database tables, you're going to have an ID. And in our case, we're also going to make these IDs automatic so that they sort of, once we add fields in, once we add instances to our tables, or essentially rows to our tables, they're going to be auto-incremented and auto-generated. Okay, so I'm going to go ahead and say, this is really something I need to really copy from here. I don't remember this by heart, but essentially, I believe pretty much I don't even probably have to copy this whole thing. If I just say generated value, yep, and probably strategy. What are our strategies? Is it going to give me a list of options? Okay, strategy. So generation type. We're going to just say identity. I think this should be enough. I don't have to copy this whole thing. Okay, so we're going to find out. Okay, so this is how we configure an entity. And in order for this entity, by the way, yeah, I already mentioned, right, that we have a Postgres database here hosted, and it already has some tables, but this is going to be a brand new table. And by the way, the way we also make it, because by default here, it's going to name this test entity. I'm going to also let this play out, and we're going to let it create that. But essentially, if I if I create this, this should be almost enough. I think the one other thing I'm missing is a repository. That's another concept in Spring, a repository. That's just something that maps this entity to a database object, because database is a whole different thing. It's SQL, right? And we need to map our Java actual like objects, like this one right here, test entity, to database objects. And repositories is just a concept that really helps us do that. I'm going to right click here, create new, and this time it has to be an interface, because it is going to be implementing some of the JPA like specification for the persistence, like to be able to do some CRUD operations. But we're also going to see that in just a moment. So I'm going to just say repository. Repository, and then we're going to say demo repository.java. Okay. So the way we mark it as a repository is by, we actually don't need an, okay, we can erase this, and actually, sorry, no, we still need this. This can be empty, and we're going to say implements, and we're going to say JPA. It's not coming up. Okay, so we're going to first mark it as a repository, right? And we're going to, where does it? I think it either implements or extends. Let me just figure out extends. JPA, there you go. JPA, which ones are we going to choose? Let's see, the choice is really big. So we're going to be implementing JPA repository right here. And it has to be a generic parameterized type, right? Meaning that we have some, this type is actually representing some other like type that we're parameterizing in here. And in our case, it's going to be really this test entity. So that's our first test entity right here. And then second parameter is going to be the unique value that represents this entity. And as you guys remember, we did do the step of making this a unique ID, right? We annotated this with an ID. And that really, here is exactly the reason why we're doing this. We're going to say integer here. And this really has to match whatever this entity has as a ID identifier, okay? So essentially, we're pretty much done with implementing the JPA repository, and this is going to let us map our objects to database tables, which is going to be really easy. You're going to see in just a moment, okay? We're going to go back into our controller, right? This time, last thing I'm forgetting here is I'm forgetting to add database password credentials and things in configurations as well, because right now we just defined these, but we didn't in any way connect it to our actual database, which I have running here in AWS, and I'm also connecting to it through my pgadmin, right? So what I'm going to do here is first I'm going to get my passwords. Where are my passwords? I believe that they are in this backend code. Yep, they're here. So all the credentials and really configuration files and environment variables, they all go into main resources, application properties, by default, that is. And I'm also not worried about disclosing all of my credentials, because after this workshop, they're all pretty much going to be deleted. So as long as you just don't interrupt this workshop and don't go and connect to this database and erase it or something, we're going to be fine, okay? So let me paste these credentials. All right, awesome. And application name stays the same. So what are these, right? So in order to connect to any database for that matter, you really need a URL where the database server lives. That's right here, right? JDBC, Postgres, whatever. You need a username for that database. That's something I already configured behind the scenes for us guys. If we had to do that as well in this workshop, we would be here until morning. It's a process with a lot of errors if you do one little thing wrong, right? There's also password. There has to be credentials, because since you're disclosing it publicly, there has to be some sort of authentication. And then these are really Spring Boot specific things. I was explaining sort of the JPA specification here, and also, like I was saying, these persistent specifications are also implemented by different vendors. And this is one little example of that you're going to see here, right? So it's using PostgreSQL dialect. If I was connecting to a MySQL database, this would have been like a MySQL dialect or something, but I'm not going to change. I don't remember it by heart. So all SQL databases essentially come with their own little flavor, and this is what they call a dialect, okay? DLL auto, we are going to actually change this to create because we are not doing any SQL queries here. As you notice, we're just going to be rerouting our Spring Boot application, and this create is going to essentially make sure that this Spring Boot project senses and scans all of the repositories and all of the entities that we created here, right, over here. And it's going to create the tables needed for us. And we're going to see that in just a moment. And show SQL, I'm going to say true. This is just a config to show SQL here in the build area, right? I'm going to save all this, and I'm going to hit rerun. So right-click, new. Oh, not new, run. OK, good. So you're going to notice pretty much, I don't think there was any errors. Let's go into our console. You don't have to have this. I'm just going to be doing this on our behalf. And then I'm going to refresh this. I hope I'm still connected. Refresh this table right here. And it used to be 2. I should have paused here and like let you really see that it was 2. Now it's 3. Demo entity, right? Now, if we go back here, so DLL options, we really can change this to, there are a couple options here. There's create drop, there is like update. If I really say equals, does it gonna it does auto-populate, but it doesn't show me all options, but it's fine. So essentially the one we're gonna be doing is, I believe now update. Since we already created this table, we can essentially now move it to update, because if we kept it at create, it would keep recreating the table, and all of our changes would be essentially erased by a new rewrite on the table. Now we created a table, but it's empty, right? Demo entity, is this the one? No, that's not the one. I need to right-click, and I need to see view, edit data, all rows. Yeah. Now it's going to be, and we're going to see it's empty because we just create. Oh, no, this is not the one. Test entity. There you go. Sorry. View, edit data, all rows, because in here we really named this test entity, and you're really seeing why we're doing it like camel case wise, right? Because it really does this real nice underscore thing in translating names. If you really did want a custom name, you could have done at column annotation, or rather a table annotation, and then name equals custom name, okay? And I'm forgetting to import these classes, okay? Let's let it rerun. I'm not sure it's gonna create a new table because we did set it to update. It's probably gonna just update this table. Let's refresh and see. So yeah, now it did create a new table because that one was already set. Okay, so it created a new table, custom table, and essentially we're gonna keep it at that, right? So just gonna verify that it really works with this one. View data, all rows. Yeah, this one is also empty. Okay, good. Now the juicy part, right? How do we interact with that table, and how do we add stuff to this database? So we're going back to our controller. So controller, remember, this is an equivalent of route. And then here we're really, from here, we are going to be calling our repository. That's why we implement the JPA repository. We also could have done this like CRUD repository. You're going to know, some of you are going to notice a really familiar name. CRUD is just like operations that are common operations to like create, update, and delete data, or and read data as well. And they are named like that for a reason, because once we extend these classes, we inherit this ability to do all of these like CRUD operations, as they call them, right? Create, read, delete, update operations. In here, I'm going to import in controller, right? We're going to say, we're going to have a member variable, and we're going to call it public. We're going to say test, or rather demo repository. And we're going to call it demo repository. So as of now, since I'm not doing a equals new like a Java, really Java way, right, of doing things, since I'm not doing this, this object is essentially going to be empty in here, right? And the biggest thing actually that Spring does for us, like forget all of these web frameworks, this is actually the biggest thing that Spring does for us, is a thing called dependency injection. I'm going to say auto-wired, and this thing is going to be populated by this repository that we annotated here, and only because we annotated it here, it's going to really sense and scan that repository, and it's going to auto-populate it here. This is essentially a difference between a library and a framework. Can somebody tell me a difference between a library and a framework? Does anybody? No, it's not synonyms. It's not the same thing as you may have thought before. Yes, please?
Pretty sure libraries, it's like kind of some functions and methods that are like pre-written just to speed up development, and then framework is sometimes it's opinionated, sometimes it's not, just like how to develop things.
Okay, you described, it's partially correct. You described it as in like some side descriptions, but the main thing that differentiates them is this, okay? So library is something that developer gets and runs his code using some of that precompiled code. And a framework is something that gets your code and runs your code. Okay, so you run the library, but the framework runs you. Okay, so this is essentially what's happening here. Okay, so we're saying auto-wired. There are some already agreed upon structures like entity, repository, right? And these are, we're just giving the framework the code. Here is our code. Here is what we're going to assume that we're calling an entity or a repository, and run this code for us. Auto-wire, inject this dependency into this field, right? So the framework really knows what you really mean by like this entity, and it scans all of these classes that you provide to it, and it essentially runs all of your classes in the appropriate places where it's appropriate. Like in this scenario, it's going to run it here in this class, auto-wired. All right. So if you take away one thing from this workshop, I would just say, yeah, the main thing that Spring Boot does is the concept of dependency injection. We're injecting this dependency into another class, like one class into another. Okay. So let's continue. Now we're going to use this repository to essentially read objects from our database and create objects from database. So we've already seen the get mapping. Let's see the post mapping, right? So I'm going to say, I'm going to create a new class, public, and we're going to say it's going to be a new class that we're seeing in this tutorial, response entity, right? Response entity, there you go. And it's going to be also a parameterized class. And we're going to say it's parameterized by the type test entity. Awesome. And we're going to name it add user, or was it user? What add test entity, okay? So this is essentially going to come with a attribute, or rather an argument, right, that we pass into this class. And the way we send this argument is by using the request body annotation in here. We're going to say request body. There you go. And we're going to say, let me use my cheat sheet. All right, so this request has to also come using the standard that we defined, test entity, right? So we're going to say it's defined by test entity class, and we're going to say, we're just going to call it test entity. And this method must return, yeah, it's already complaining that we're not returning anything, so we're going to say return response entity parameter. We're going to actually say new response entity. And what we need to pass here, first argument is going to be the test entity that we end up like manipulating in here. For now, I'm just going to create a test entity as such. Or or actually I'm going to return this one that they're already passing, test entity. There you go. And the second one has to be a status code. So I believe here in my cheat sheet, I do have an example of the status code. Okay. Yeah, and the method is literally just HTTP status code, HTTP status. Yep, this one, and then okay. Awesome. And what is it complaining about? Return. We're forgetting the parameterized. So yeah, this is a parameterized. This is the way you tell Java, hey, whatever generic we're using here, just use it here as well. Well, official way, if we're all like buttoned up, we can do the full version, okay? But new Java allows this, inference of parameterized type. So how do we now connect to our database and really try to add this entity, right? So this is a post mapping, and the way we're going to annotate it is literally as such, post mapping. And we're also going to do it, we're going to name it user and or test entity. We're going to name it test entity. This is this is a convention, okay? We're just I really also needed to name these test entity, but I'm going to make a different methods for those. Essentially, you just create a route for whatever you're trying to either update or fetch, and you differentiate what you're really doing with it by the mapping. So in this case, it's a post request. It's going to know, so treat test entity as with a post request. And if I create like a different one, a different method, and I'm going to say something like, instead of post, I'm going to say here get. The way Spring is going to differentiate between those two is by the request mapping type. So essentially same URL, but just different HTTP methods, right? So yeah, this I'm going to remove for now. We're going to go ahead and try to save this in our database. So we're going to say demo repository dot save and entity. Entity. Okay. What are we missing here? What are we missing here? Oh, we're not missing anything. Did I rename it to CRUD repository? GPA repository. No, everything's correct. All right, let's see the error status method here. This is a string. Okay. This is a wrong method. It's supposed to be a what? Yeah, I think it messed up this whole thing. This is really supposed to be the one. And we're supposed to say demo repository here because we're passing a test entity. I don't know, I got fooled by this IDE somehow. It gave me a method with a string. Now we're calling it here, test entity, whichever we were passing here. And this is how we actually save. We use the repository to save whatever we're passing here. And you're going to notice it's a test entity. So yeah, that's how Java is really like strict about what we're passing to our endpoints. And we really have to pass it in the format of test entity, which is defined here, test entity, right? So it says everything has an ID, or rather ID is auto-generated. Everything has a name. ID is auto-generated. So we really need to provide a name to this entity in order to save it. So I'm going to go ahead and test this endpoint. Looks like I'm not getting any errors. Another tool that backend developers really use is Postman. We didn't go over installing that, but essentially, this is a tool that you can just look up, download, and I think it doesn't need any support. So, excuse me, we're going to use the same endpoint because it's still 8080, and this is just some endpoint I was testing earlier. And I'm going to use this endpoint as test entity. Boom, and I'm going to use the post request. So now let's just try send it empty, right? Because we need to test how it looks. So request body is missing public string framework. So essentially it's saying we're missing a request body. This is what we're expecting to receive because we are not providing this request body. And we are going to provide it now. We're going to say name, and we're going to say user1. So now let's try to send it. And we get back essentially the same thing that we sent because we configured it that way, right? Return new response entity and send back that same JSON and say status is okay. Status is okay, good, right? Now let's do the fun part. Let's test the database and see if this little demo repository was really enough to do the job and connect to the database, right? So I'm gonna refresh, and I'm also gonna refresh this. Now we're gonna see user1, user1. If we send in user2, then it's gonna also update user2. Awesome, right? So this is the way really we just use the repository pattern and the Spring's ability to extend behavior from like just common classes that they define that really implement common tasks such as create, delete, and all these operations. And this is the way that we extend them and essentially interact with the database. The way we really fetch these, let's try, and now that we have a bunch, right? Let's make a get mapping because these get mappings were really just the hello world ones. Let's make a different one, public, and this time it's going to be a whole list of these entities. So in Java, you really just when you want to send back a JSON that's a list, you use the same like REST mappings, and you also just identify it as a list, and it's just going to be a JSON list instead of a JSON object, right? So we're going to parameterize it by list, parameterized by a test entity, and we're going to say get test entities, right? And request body is going to be nothing because this is just a get request, and then list, of course, we're not importing that. Let's take care of that. Awesome. And here we're going to use demo repositories. So essentially, you know how save, right? There's no save in here. Essentially, that's something that comes from this. If I alt-click on this repository, there's going to be really a bunch of methods that this provides. And these methods are, well, actually, here you're probably not going to see any important ones, but list CRUD repository, list paginated repository, and all these repositories, they all have some implementations here and there. For example, save all. If you have a list, if you send it a list of something, find all. So essentially, all of the CRUD operations, if you really dig down, CRUD repository right here, right? Save, there you go. Finally, we found it. So if you really dig down, we are inheriting all these abilities from all these classes in the repository, in the Spring repositories, and that's really the way we're able to like use these classes. Oh, sorry, methods. And this time, what we're going to do is actually we're going to do find all, right? This is also one of the methods that we're inheriting from Spring data, and then we need to save it somewhere. So we're just going to say list, or rather, what am I doing? I need to parameterize it by test entity. I'm going to say res for result. And we're going to save it in here. And now it's really complaining about us not returning that, whatever we promised to return here, right? So we need to code it up. Return new response entity. It's going to be parameterized by, or rather, we don't have to say that. We just send it in list, or we actually just send this res. This is our list, and we say the same way we did here. We say HTTP status okay. Now the only thing left is to make it also a endpoint, and we're going to say get mapping. Yeah, this is how it tricked me last time. It created a new method. You see here, I just said get mapping, created a new method, and that's how we got that error. So it does a little too much for us. This time we spotted it. We're going to say test entity, and this is what I was really talking about, right? So when you create your endpoints, you really name them the same thing, but the only thing different is just the method that you're using to call them. So this was a post request. This was a get HTTP request. Now we're gonna, there is some warnings. We're not using some of these, so let's delete this. All right, awesome. Now we have this endpoint. Let's test this endpoint. Let's see here. We can even test it in browser, by the way, because browsers by default, they they do perform get requests for us, test entity. And this, voila, this really returned us the list of all of the entities that are present in our database, okay? So it did return it in JSON format. As I was briefly explaining, I didn't go in depth into this, but this is JSON format. We can pre-print it. This is how JSON looks, right? You've probably seen this before. And really the way it happens, right? You might be wondering, how does Spring know to convert it into JSON? So really, when we put in these starters as our dependencies, these are also combinations of other dependencies, other packages that really come inside. So if we really dive deep here, we can open up this tab. No. Oh yeah, this is it. Yeah, Maven dependencies. So there you go. So there's a lot of dependencies here, and one of them is going to be this one, Jackson. So Jackson is a library that converts Java objects into JSON. So essentially, if you were wondering, yeah, this is something that is done under the hood, and this is something I was talking about earlier, a compromise between like getting things up quickly and making it work, and a alternative of that is that, or rather a cost you get, is that you don't know how things are done in the hood. You just have to believe all these packages to do the job for you, okay? What else? Now let's, I guess we're already running out of time kinda, and we are going to be, I don't think we're gonna implement the whole application, but you're welcome to see this coded up version and try to also install and play around with this. It's in here in the backend. But essentially, the thing I'm going to leave you with is, lastly, let's just discuss how to handle errors here in Java, right? In these controllers. So we're going to go ahead and make a scenario when, for example, we create. Let's first, yeah. One other thing we can do is make this name field unique, right? For example, in SQL. It is really a thing to make some attributes unique. For example, if I insert a user2 here again, right, it's going to be a collision. Those two users are going to have the same name. So we really need to make it unique. And I believe we can make it by saying here column, or rather column, and then unique true, right? Yeah, that's the way we do it. So now I believe if I restart the database, sorry, restart the Spring Boot, and we refresh the database, we should really just see. Okay, I just remembered that right off the bat, it's not going to work. We're probably going to need to recreate the whole database. So I'm going to say here, I'm going to say create, okay? So this is essentially going to, when we restart the app, it's going to drop all of the tables that we had already, and it's going to recreate the database from scratch, which I'm going to do just that. So because we had a new, essentially a new requirement here, normally you would typically just do it at this requirement as well in parallel here using SQL. But since I don't remember those SQL queries by heart, so I'm just going to do the easy version, recreating the whole database, right? And now you're going to notice if we just refresh these are all going to be empty. Let's verify that. Yeah, they are empty. They were recreated. But now there is really a requirement here that the name has to be unique, because that's something we added, and that's something we refreshed and recreated the database with that requirement in place. All right. So now if we try adding that user again, we can still add user2. We can still add user1. But if we add user2 again, we're going to get an error, and that's what we were hoping to see, right? Data integrity violation exception. So let me quickly just show you how to handle exceptions, and I believe we can just call it a day, right? So essentially, some situations are going to arise where your backend logic really just wants to not break in the server, but just wants to gracefully return some error message to the user and just want to tell them that, hey, something went wrong, try another day, right? We see this all the time. In our hello controller here, where we post to the database, we're just going to add a try catch block. This is also something a Java, essentially Java feature. You're specifying the type of exceptions you're trying to catch, and then you are dealing with them in this catch block, right? So the type of exception we're seeing here is the data integrity violation exception here. So we're gonna specify specifically. We're gonna say we're trying to catch that exception, data integrity. There you go. Auto populate. Yeah, it did get imported. Now we're just gonna call it E, and we're gonna say response entity. So here, right, if it worked, this is the behavior that we're expecting. But if it didn't work, there's the catch block, and we're gonna say still do like respond a normal response entity, and this time essentially just well, let's make it like this, that it essentially finds all of the users and it checks if there is a user with that entity. If it does exist, if that user does exist, it's going to return that user. If no, it's going to save that user, right? So essentially then at that point, we're not even going to need this type. We're just going to create a generic type exception. And this is essentially going to be our catcher. But what we're really going to do is we're going to say test entity. And we're going to say query is going to be demo repository, and then find by essentially find by name. Oh, this is really good that we started talking about this. I also want to teach you guys this little thing. So find by name, right? We stumbled upon a thing that we didn't have implemented. We're inheriting behavior from JPA repository, but it's not implemented in that behavior. So there's something that we do need to implement ourselves, right? But we actually really don't. Spring also took care of that scenario. And this, so we're going to pass in here, right? String, and we're going to say test entity dot name. So this test entity, or actually we don't have to say spring. Okay, good. So find by name really doesn't exist, but we can go into that repository and we can really add things, our default custom things here. So for example, in our case, it was a test entity, right? We're searching up test entity. So if we find one, we return a test entity, and we're going to say find by name, and we're going to pass in string name. So what is it complaining about here? Test entity is not visible. Problem. All right, so in this repository, we're passing string. This should be correct. Dot find by name, string name, right? So test entity name. Does it really have a name property? Yes, it does. Huh, interesting. Yeah, it's a silly mistake. I really should say get name. Okay, it really caught me here because name is a private property. Yeah, we have to access it publicly. Okay, sorry. It was just to check if people are still not sleeping here. Okay, so all right, so we get a query, and we're gonna say if this query, this is really just a nice way to do that. We can fetch it, and if it's not going to be in the database, it's going to return null, right? So we can say query equals null, and if it is null, then we're going to create one, or essentially we're going to save this one. If no, we're going to gracefully just return that one. And in any case, we're also going to catch an exception if there is one, and we're also going to return pretty much essentially whatever was sent, or we can even return null if you want. But that way, we're also returning something and not just like crashing the server, right? Because the server was only restarting because we have it running here. But if it really crashes in production, it's going to just stop working, okay? That's why exception handling is important. So we're going to say if it's null, then we're going to move the save part. So demo repository.save, and then we're going to say test entity. Otherwise, we're going to say, and then here also we need to return new. I'm just going to copy this code. We're going to say, yeah, return that one, but otherwise we're going to return this one, because remember we already fetched it, and we need to return specifically that one because the IDs are otherwise are going to be messed up. Okay, and then we still have to delete this to take care of that warning, and we're going to say we're good. Okay, let's test this now. So now I have a new user. I'm going to post user number 4, right? 4 is something we didn't insert. It's going to insert user number 4, but now if I insert it again, it's just going to return me the same one. So that's our kind of like little example of how to deal with that exception, right? We can also specify here that since we're not returning here in this block, we can just say system out print. So this all Java thing is still working here, and we can just say we are in this block. So now if I maximize this console and if I clear out all this stuff, I'm going to just go ahead and say here. So we're actually not in that block. Because y equals null. Hibernate. Yeah, for some reason we're not here. Why are we returning early? I need to restart the server. Yeah, it's not gonna let me finish cleanly, right? All right, restarting the server. Post request. I guess system out print doesn't work. Well, okay, I guess, yeah, sure. But essentially, yeah, logically, since we have this query as null, it really does go here. Probably I have, I have to specify here that, yeah, print out all the logs, all the levels of logs. I remember something like that. But I don't remember exactly how to do that now. So let's just wave a hand at that. We're going to remove that printf or system out print. And we're just going to trust that it's going to this case, right? And if I, for example, if I provide something, some like malicious value, for example, let's say we're providing a number instead of a name, that's a bad case. It's going to go into this exception case, and hopefully it should return a null here. So actually, oh, it even converts it to a string, so never mind. I guess if we try to make it other equals other, maybe this is going to break it. Because now I'm hoping to break it, now I cannot break it, right? Okay, now it did break it, and okay, so essentially it was another error that that was not cut here. But essentially, yeah, we're just gonna pause here. You get the point. Exceptions are caught here. Looks like this is really the type of error that is really caught earlier than this, because technically this is a JSON error, and JSON, like I was mentioning earlier, is handled here in Jackson library. So essentially, yeah, it didn't return as null, but we can essentially try to just at least see here if we still like have this. Let's go back here. Let's see if it can return null, like now, if it finds it. Okay, doesn't even return null here. There's something wrong with this. Okay, now it does return null. Okay, so I guess query almost goes here, which really means that our find by name probably doesn't work properly. Yeah, our find by name probably doesn't work. So let's see here. Am I making a mistake? Just a moment. No, user find by name. Get name. All right, bear with me. Get name. Yeah, getter is there. Okay. Find by name. String name. Test query. Okay, so if it is null, save one. What if I say if it's not null? All right, let's do some troubleshooting in here. Database is restarting. Okay, so now it is. So now the exception case is working. Okay, I guess it's supposed to be not equals to null. Anyways, yeah, I think I'm too cooked at this point. I'm just gonna resign. I'm just gonna.
Why the print statement didn't work.
Yeah. Maybe that messed up with it. I guess. Yeah. We're just gonna end this workshop. Yeah, we already went pretty much over time. Thank you for those of you who stayed until the end. Thank you for your attention, and for those watching online as well, thank you. Have a nice one. Thank you for your attention. Bye.
Tell me exactly what parameterization means in Java.
So parameterization.